We three will give a insight into facade design analysis. So, to give a brief introduction about how the evolution of the facade has been, starting from the vernacular architecture, which the very word vernacular means native, local. In those days, it was houses were built of the local materials with the traditional construction methods that were followed, like the houses that we see in traditional Rajasthani houses with the jarrokas and the jalis and the big blank walls to protect it from the sun, the sandstorms and other things. And also, if you see the buildings in the northeast, which are all built of bamboo, which is locally grown, and the pitched roofs on the high plains to really protect it from the floods and the high monsoon that prevails in that area. But with time, then we came to the with the colonial architecture, things changed, and there was a lot of introduction of Gothic and English features into the facades. It was dominated. The facade was more of an open design with arcaded columns and domes, motifs, right from the Victoria Memorial to the culmination of all the buildings, Lutyens, Delhi. There's the Parliament House, the India Gate, the Rashtrapati Bhavan. These are characterized by the grandeur of scale and the use of the cut stones. We see a very different elevation, the facade change in a total change in a facade. With the post-independent era, what happened is RCC became the very popular material. And during this period, there was an adage of form follows function. So the function of the building was the main focus and everything follows. Even the facade design was based on the function of the building, just like how it is in the High Court in Chandigarh, Punjab and Haryana High Court, in the Sri Ram Arts Performing Arts Center in New Delhi. So the internal functions are reflected in the facade, in their forms and in their treatments. But moving on to modernization with the changing lifestyles, with urbanization and new building bylaws coming into force, the entire skyline of the cities changed from low rise to high rise buildings. So, started with that, the use of glass. Then there was a dramatic change with globalization. That is where things really went heavy. Like we see any building, whether it is being Chennai or Kolkata or Mumbai, all of them extensively used structural glazing and aluminum cladding. So now the facade became it just like a cover pulled over space with total disregard to whatever climatic conditions or regional or local context or the efficiency of the building as such. So that is where things went very wrong. During this time also we can see in Gurgaon so many of those cosmopolitan architecture buildings full of glass facade came into being. But what happened in reality is the whole of Gurgaon was without power supply. The residential houses did not have power supply. They had power cuts for long hours. And people used to come to offices and work because all their glazed structures were fully air conditioned. Not only did they get overtime, but also there was power supply and a very conducive environment. So, with time, we also learned that the meaning development means for developed nations, it means a step beyond prosperity. For developing countries like us, the word development means a step towards sustainability. So there was a great awakening, and now we started moving towards sustainability with Griha and IGBC into force and giving accreditation to buildings. There's a lot of encouragement towards sustainable design and sustainable architecture. So once this has come into being, the facade as such has become a very important part of the building. Not only the facade integrates to the architectural context, but it also plays a major role in the building efficiency as such. So what happened is the facade plays many roles because it has to control the light, the solar heat gain that enters the building. It also has to stand the wind pressure it is exposed to. And it also has to stop any seepage or leakage coming, and as well as it has to provide thermal and acoustical comfort for the inhabitants of the building. So you see, the facade has become a very, very important aspect. So came into being the facade consultants who really, really play a key role in really analyzing the skin of the building so that the building efficiency is such is enhanced. So that is how why we have taken chosen this topic to address today.
As Madam has already told, there are lot of important features which can be achieved due to the facade. Today, facade has developed in such a innovative way कि you can't imagine what leap it has taken from the history of the era, if you can say. The facade, like in Gurgaon, once upon a time was famous, but it had lot of disadvantages, as Madam has told. Irrespectively, what I personally feel कि today management of facade also is very important irrespective of design and construction. I would wish to know a lot of things from Mr. Mitul from his presentations, and then we will carry out the further discussions. Mr. Mitul, please.
Thank you very much. First, I would like to thank ma'am and sir for this opportunity to touch upon this subject, architectural facade design. Facade design, if you see today's world, if you go around the world, you have a tall building, a glass building, a cladded building, the high-rise building up to 600 meters, 700 meter. But these all facade which is standing, they are passes on some of the parameters. Oh, those parameters are equally important because the reason the building has to be sustainable, as says ma'am, it has to be stand for next 50 years of years life cycle, should have maintainable facade. So there are a lot of points which to be taken care of during the design stage, which I'll touch upon. And for that, I think the facade consultant plays the major role, as it is the prior to the execution of the facade. You can on the screen audio says the isometric view. The architect designed the building as per his imagination. He says with and sit with the client and he say, I want to do this facade and let's have the such kind of view. But then he is stopped somewhere because he doesn't know which material has to be used, which system has to be used, what is the climatic conditions, what are the other parameters, what are the safety norms to be followed. So they hire a technical specialist who is a facade consultant. So I'll touch upon with one of the project. I'll take you on the tour. What are the main subject we are covering during the design stage. So one I spoke already regarding when the architectural design has been designed by the architect, we make sure it doesn't change the aesthetic what he imagination during the design stage. Now the buildings are coming at which location is more important. Like the building is in west of India or is in east of India, north or in south. Like weather condition, if you see in the north, you have climatic condition up to 0 degree or minus degree or up to 45 degree. When you go to south, again the temperature is moving not that much, like it is from 20 to 40. When you come to east, it's again humid conditions. So India is such a vast country and there are a lot of weather conditions separate, and we need to consider those weather condition during the design stage. Now same way it is to wind pressure. Now when we say the wind pressure, again you see that the all in pan India level, the east of Calcutta or maybe those area, the wind pressure up to 3 kPa. Where we go to Bangalore or maybe south up to the Karnataka, the wind pressure only up to 1.2 kPa, 1.5 kPa. Again we go to back to Chennai, the wind pressure is a cyclonic zone and there's a wind pressure is very high. So during the design stage only we consider that what is the wind pressure, the building location we consider, the building height, width and depth of the building, and we derive what is the wind pressure on this. Like again the third parameter is the seismic requirement, like earthquake zone, like if the building is in somewhere Bhuj earthquake zone or somewhere it is in North India or East. So we need to consider which are the zone the building is standing upon, and those parameters to be taken care of in the design. So along with this building facade, so it makes sure that during certain earthquake, the building sustain, including the facade stability. The dead load is nothing but the load which is transforming on the building. So there are certain loads of the facade which we need to give it to load to the structural engineer to take care of when he designed the building. So he take care of that load and the structure has been developed. The live load. Now the building has always a live load. Even you make a skylight, the person is going to walk for some maintenance part, the cleaning part or repair part. So those live loads we need to consider in the design. It's also, these are the technical design which we consider. So these we call as a design based report. We call as a DBR. So this DBR is more equally important when we do the before the finalization of the tender stage. So entire technical design. The glass performance. The glass performance is like for IGBC certification, the humid conditions. We need to find out what glass is correct. And now in a glass, there are a lot of different colors which architect likes. Then what is the U value we want to achieve? What is the thickness of the glass? We need to consider DGU glass or single pane glass. Like if you use this glass in Uttaranchal somewhere, the temperature never goes more than 32 degree, 33 degree. So we can use a single glass over there. When we use it, it's somewhere in west or certain place, very humid area or very hot area, we need to go for DGO glass. So you get a better U value and the light transmission also. The fires, again, now the tall buildings are coming in, the fire stop. There, when we say the fire evacuation systems are there, including there are certain parameters to be passed in the facade. Like we have a floor to floor ceiling, we have to compartment ceiling. Then there are the refuge area where the fire facade also installed over there. Openables has been provided for the evacuation of the smoke. So these are the also discussion happens during the design stage. And the facade option, last, the architect has designed the building and he has given some option that I want to see somewhere glass, I want to see somewhere cladding. So which kind of system will go on the glass facade, which material will go on the dead wall, which are the product will go on the HVAC area, which are the material will go on the duct area. So these are the overall taken inputs, and the design based report has been derived, and then the technical part goes into this. So I'll just cover, I will take it the tour now. So this is we are taken a typical building, which is the high rise building, which you are talking about 120-meter building, which is in a hot climatic zone. So important building we consider as a high rise building. So we have discussed on the different parameters, and these are parameters I'll follow in the other sheets. Now I will find out what is the location of this building. So location of building was in Gujarat. It's again we can show you can see in the map the location of the site. Now this is the weather condition of this area. The maximum temperatures goes 43 and the lowest is 13 degrees. This is the average temperature. It may sometimes goes to 45, but the average, if you see the entire year, the temperature goes, highest temperature is on 43 degree, where the lowest, which is going to 13 degrees centigrade. So when we have designed this glass facade and we are selected the glass, we have taken consideration of this weather conditions. We have seen the wind, when the wind is the highest wind. So we can consider that on the July, the wind is on a very high side with the rain. So basically you can see the July, which shows that it's a very heavy windy area in this region. So this is basically the overall chart of maximum minimum temperature and so overall sheet we have derived this will help us during the design of the facade. So now again this is where the building is coming up, is again Gujarat. So again it comes as a hot and dry area. It's not a humid area. The Gujarat is especially visit Ahmedabad is a very hot, we can say predict to be hot and dry climate. It is not a humid area. The wind pressure. The wind pressure is basic wind pressure. We normally use the IS code, which is 875 part 3, and the basic wind pressure for the Ahmedabad is 39 meters per second, which is a gift city area. And we have designed this building for 50 years life cycle. Just for important, there are other codes says high rise building and a very important building should design for 100 years also. But this is only a tall building and it's a commercial building. It is designed for 50 years life cycles. So these are the parameters, and we come down to calculation that the 2.1 kPa wind pressure is the highest wind pressure is going to be act on this building. So this is the chart from where we found out what is the basic wind pressure. This is IS 875 part 3. We found out the 39 meters per second. The wind pressure is considered. Now the wind pressure is coming as a 2.1 kPa, but that is the entire building. So what we have derived that we have to also economize the system. Should not take a 2.1 kPa wind pressure at the very ground floor level. So we divide in the three parts that the up to 20 meters the wind pressure is only 1.2 kPa. Is the wind pressure is always the lower side is on up to 20 meter. Then we are considered up to certain floors which is 1.75 kPa, and the above the 70 meters or 80 meters the wind pressure is almost around 2.1 kPa. So this will help us in the not over designing the system, basically to overcome the when we are achieving this such kind of building, the cost is on very higher side. So economic system, we make sure that the wind pressure is not applied on an equal basis. So this is the which we call the up to 12 meter height the wind pressure is considered as a 1.2 kPa. Up to 52 meter height we are considered as a 1.75 kPa, and total height of 120 meter we have derived that the final wind pressure will be at 2.1 kPa. So there we also check that the what is wind directional. So it is a southwest wind direction, which is a heavy direction. So we during the design we make sure that we don't use such a kind of product which is very flimsy and which is flown during the direction. So this is basically now the seismic requirement. Again, you know, earthquake zone and pan India basis, there are different seismic zone has been derived, and it comes under this area. It comes under seismic zone 3. So this is basically this consideration we taken during the design. So we give the play in the system. So when the earthquakes happens, it takes care of the movement of the earth and the system safe and remain without the damages. The load consideration. So I have told that the dead load, the system load which should be given to the structural consultant to make his building safe. So these are the standard weight which is to be given to the structural consultant, like aluminum 2700 kg per meter cube, glass is 2500 per meter cube. So he takes care of these inputs and he designed his structures. Before the building comes up, these loads are already with the structure consultant and he designed the building. So live load is already this is based on the IS 875 part 3 live load and everything. The canopies, the live load. Live load, again we told about that there are canopies, so person will go on the cleaning part. So we are considered a 75 kg per meter square. Then next is the skylights. The skylights on very higher level and there are bigger skylights. So then we are considered is a 150 kg per meter square live load. There are certain skylight which is not required. There is no accessible skylight. Just for the cleaning purpose. So again we have taken a 75. So these are how we have derived a certain live load on the facade, which also takes care of during our design and calculations. The glass performance. It's the most important thing which we need to take care of during the design. First, the dB level, sound level, building is standing in which location, like it is standing in the crowded area. So your dB level outside is 100, you want to bring it down to 80. So what thickness of got, what is the air gap we need to consider in DGU. So these are the study we do it and then we come down to the conclusion. Again, the second parameters, the U value, the light transmission. We normally suggest to go with the better light transmission. So you get a natural light inside, and there is a less load on the HVAC and we can save some energy. But overall, the glass has been designed as around dB level, the glass performance, and again the temperature outside, inside temperature. So though there we suggest the glass and the architect select the glass according to you want a color of glass, blue or green or gray or a clear, you select the glass. But then if we reached out to performance criteria, we will select that okay, my VLT should be between the 20% or about 20%. So this is the typical glass parameters we are considered for this project. So glass is for many manufacturer of the glasses in India is readily available in India. There are double silver coated glass what we are considered, and we are considered as a DGU glass where we told that the client that should be the glass should be selected where the light transmission should be between 27 to 33%, a hot area, and it's a dry area. So there is a lot of light reflection on the glasses. So we do a little bit on a darker side. Normally, if you want on a clear side, the glass light transmission should be above the 40%. So we are told here that you can go up to 30% of the light transmission. Light reflection this is the more important again. Light reflection from outside and the inside. If you have more reflection from the outside, if you go above 25 to 30%, you can see the mirror effect. Same way if you do it same way instead from inside, if you do about 25-30%, you can see your image in a glass. So we always suggest that you should go for soft glass which will have a reflection lesser than 20. So it's like a see-through glass and which will have a soft look and aesthetic point of view. And also it doesn't reflect the building from outside. It's look very odd and it's look very shiny building. So U value normally it's by the HVAC say we want up to 1.6 U value you want to consider. So we have derived that yes it will come down to up to 1.6 U value. Now when the glass has been selected, there are a lot of parameters which I touched upon. I'll again say, so same will convey. The color of the seen from outside. The architect wants the view that okay I want to see in a grey shade of the glass or a blue shade of the glass or green as that. The internal external reflection which then I told. There are some pattern design will come on the glass like a ceramic frit pattern. The safety of glass, we say the high rise building glass they can go for a laminated glass. So these are the parameter, the U value, the solar factor, so these are the performance criteria we'll discuss during the meeting and finalize the glass. The safety of the glass, of course, the tall building is there. You need to understand the safety of the glass. Glass should not fall down. The openable should not. Injury to human being should not be there. So these are the safety parameters. We'll take care of it. The facade cleaning also we need to take care of it. The system has to be in place. The due to wind load, the glass should not have a deflection. There is a parameters given in a standard that in a heavy wind pressure the glass should not deflect up to 20% or more than 20%. So we check the structural calculation. We see what is the deflection in the maximum wind pressure, which is 2.1 kPa. So we derive that okay the maximum deflection on 2.1 kPa is only the 12%. So it is so glass we can say is the safe on extreme conditions. So glass again I told about the laminated glass, the double DGU glass because it was Ahmedabad and a hot region. So we are used as a DGU glass. It has been used as a 816 8 glass. It's a high performance double silver coated glass. So this is the basically U value again the same upon openable vents. Yes, on a fire safety mount we need as per the standard. It says every 10 meters should be openable. So we are providers openables on that. Then there are some cladding materials. So cladding material we are selected should be a fire rated cladding material. There is a refuge area that is coming up. We are given a fire rated refuge area which pass down the 2-hour fire rating. The facade option what we have selected like there is a double-eyed glazing which we have seen it where we are told that okay the verticals only goes on and the mullion depth has been approved. We have seen as per structural calculation we need up to 220 mm and the sleek facade we have designed it for them. So it's look when you go on the double light from inside it's look very beautiful from inside. These are railing where the safety railings which was given with the central laminated glass so person can very stand up on the balcony. Now building has a very tall building so we need to see the practicality of fabrication installation also. So we thought about going with the unitized panel which is a prefabricated panel in the factory and which is installed at site very easy. So there is no so factory has a fabrication has a zero tolerance on the manufacturing and it comes on the site and just install over. So there is no lateral movement on the site, very easy to installation and the high rise facade we normally recommend for the unitized panel. We are given here as a sunshade, you can see the aluminum profile which installed from the exterior side to make sure the heat which is coming on the southwest side, it's cut down and give a better ambient temperature and the daylight comes into the facade. So this is I am covered on the technical aspects of the facade. So thank you very much ma'am and sir for this opportunity. Would like to know we can further.
The presentation was really interesting and very informative. Mr. Mitul, there is one basic question. Can we go for only for low-rise building also or only for high-rise building? Kindly clarify. In facade designing, can we go for both the options?
Yes, sir. It was a very wonderful question that should have a facade consultancy on a low-rise building also. So I will say yes. It is more important also. Because the wind also act on the bungalow or a smaller building also. Because when a smaller building when we design with the economical system so that whether with the economical system taking the wind pressure or not. When you do a bungalow design, you want to take care of the safety. When you want to do a laminated glass or sliding window, we are doing whether the window will take care of that the rollers are which is there which is correct or not. So overall design of the facade to be consideration when you do a low rise or high rise. The building can be a 10 meter tall or maybe a 700 meter tall. The technicality of the design is always there.
Mr. Mitul, I would like request you to really address specific to the case study how you arrived at that design of the facade based on your analysis.
Yes, ma'am. When the architect has designed this building, it's oval, but we see that it's an oval kind of shape of building, and entire building is cladded with the glass. The other system has been taken in the core, and the building is entirely cladded with the glass, and it is standing in the open area of the building land, and there is a heavy wind pressure is coming over always there. So what we did it, because considering it's a tall building, we did that key, okay, the entire glass is there. So let us have a system which is very easy to install. So we go on with the unitized glazing, which is the latest technology available in the market to install a facade which is very easily fabricated in the factory and install at site. When we designed the glass, we had taken the consideration that temperature is 45 degree to temperature is coming down to 13 degree. Then the U value or the dB level outside is around 100. So we wanted to have a dB level around 40. So we had taken the glass of 8 mm, the gap of 16 mm, and the inside also 8 mm glass. So there was a total of 32 mm DGU glass we used install in this project to make sure that we get a better U value which is less than 1.5, and better light transmission we get it, and better aesthetic view from outside also. Glass is selected as a grey glass, typical. It was the selection from the architect. We have given a suggestion of the 3-4 glasses like a green shade, lighter green shade, lighter blue shade, lighter grey shade. But eventually, architect and a client gone ahead with the grey glass, which is their look that they are meeting their expectation. So now the glass has been unitized glazing also been used. It's very easy to install. It's a floor to floor installation, and it's take care of the entire wind pressure, which is act as a 2.1 kPa in this building. If you see that building, if there is in this building there is no other material, but if you see this building on a refuge area, as per the norms, the refuge area should have a wall, but here architect wanted to have a glass. So because the inside tenant who is there, you can see through. And so we told that, of course, you want to go for such kind of facade, we need to have a fire facade. What we do as a fire facade, it's an entire facade with the 2-hour fire rating material has been used with. Like MS is the frame where we have used it. The glass which is also certified for the manufacture with the 2-hour fire rating. The silicon and the other thing which is a closing junction has been used as a 2-hour firing material. So entire the refuge area, the facade has been installed as a 2-hour fire rated facade over here.
Yeah, one more question, you mentioned in the beginning, since the wind pressure varies with the height, you also use different types of glass so as to economize the cost of the glass.
Yes.
So can you throw light on that?
Yes. See, if you see the ground floor, we are saying it is 1.28 kPa. So the glass which is ground floor we used is a single glass, which is because it is going inside a certain building. So we have used a 12 mm toughened glass, which is installed on the facade basically. And this is the glass is on a cost part very economical. The DGU glass, it might be 4,500 rupees square meter, where the 12 mm toughened glass is only 2,000 rupees square meter. So during the wind pressure, we use the glass as 12 mm, but a single glass, because the sunlight is not coming on directly on that area. So we are used as 12 mm. When we gone ahead of the certain area up to 1.5 kPa, what we did is a 8 mm we are kept as in outside glass as 8 mm only, to make sure we don't see the change in color. But inside we are from 8 mm we come down to 6 mm, because it's taking care of the wind pressure of 1.5 kPa. So there we are saving on the cost of the glasses. So eventually the glass and that gap of 2 mm which is reducing glass, we adjusting in the system. So eventually facade look in the straight.
So Mr. Mitul, the clarification is fine, but I am worried for buildings apart from usage of the glass. Say for example, there are so many other materials which are available in the market, right from natural materials to the manufactured materials. So have you ever used the materials or technology apart from glass in any of your facade designing? And if so, can you quote some example as such?
Sir, I think building what we have taken is only the glass facade. But there are a lot of buildings which has a glass, and there are a lot of dead wall. We can say that wall which is coming into the backside of the area. So today's in a high-rise building, if you just leave the structure as it is, you have every 5 years, 6 years there are crack filling, then the plaster and then the paint work is going to happen. So what we derive that let us have some dead material on this facade. Like we can start with economized system, like we have a ACP cladding which is now rated, but still we consider an ACP. There are stones, natural stones, which is also installed on the facade. There are clay tile, which it's a natural product, which is also we can install over here. So there are a lot of project tiles. Now there are porcelain tiles comes in the market, they install on the tile. So eventually we sit with the architect and we said, okay, now this is a dead wall area. What you like to see? There are the number of material which is available in the market. Number of these materials are has a own shelf, like life of the facade. Like clay tile, we can use up to 25 years. ACP, of course, will have a shelf life 10 to 12 years, maximum 15 years, not more than that. And then if the building has to stand for 25, 50 years, then we should go such kind of product like a natural stone, which it doesn't have is a life of 50 years. A clay tile will have a better life. So we recommend that way. Okay, but still again, architects say no, I want to go with this kind of product. Aluminum cladding also come in the market nowadays. So there are a lot of huge number of options are available for the dead wall area. Apart from there are HVAC area where the fresh air is required up to 60% of the airflow required by HVAC. So where we put up a louvers which has elliptical louvers or Z louvers, will provide in design such a way that we get the airflow up to 60% inside and the HVAC performs in a better way. So there are a lot of other materials we also used it. Ground floor there is a spider glazing, but we use it. There are automatic doors. So overall facade we have a skylights which is on MS structure, we use it. Tensile fabric which can be used it.
Can you really explain? You really explained beautifully the factors that are involved, how the whole designing of the facade is done. But can you go in detail with respect to a case study? That would be really interesting.
Yeah. Okay, ma'am. I think I'll show you one of the project where with the detailed design. So I'll show you on the screen. If you see this is one of the project we had done it in Calcutta. I'll show you. This is the green bridge which has a unitized glazing. This is a very big dome which is a big skylight what we have designed over here. This is a gray part which is here, which has a double skin facade. There is a inside there is a sliding window, and external there is a glass facade over from bottom to top. There are cladding material which comes on as a pink as on a dead wall area. These are structure paint. These are the dead wall which they wanted to have with some stones. So we have used as a stone. So if you see, this is the double skin facade. There is a unable to see on screen. But if this we are done with the spider glazing, which is a double skin facade. If you see this, the building, there is a gap of 600 mm which over here, which I'll show you in technical. You can see this. The spider, there's unitized glazing inside the first skin facade is a unitized glazing, which is on a main building, and there is a bracket coming out of from there, and there is the spider which we are using. So this is called as a double skin facade, which is here. If you can see that also here there's a building which is coming. There's a window and there is the spider glazing and there is a glass. And we have given for this air ventilation, so it become the air is come from here and it passes. So there is no become a hot chamber over here. So it's a spider glazing with the horizontal gap which we are given over facade over here. So this is basically double skin facade which we had discussed over here, which is a double skin facade over here. Then if you see that we have done is a installation of spider glazing, which already touched upon earlier also. These are the panels are the prefabricated. If you see, this is a floor to floor is the facade, and we have made the floor to floor panel. So brackets are installed at floor to floor, and then the panel has come out from the factory, and with the chain pulley the panel has been lifted and then installed over here. So if you see that this is the panel size, if you can see this is the bracket, you can see that, and this is the panel which comes over here, and it's a fixed and the bolting is done. Bolting is done with this panel. So it's very to install easy. There also we have touched upon the fire smoke from below floor to upper floor. So we have used the smoke seal over here, which can be done with there are other products available in the market from the LT or some other product, which can also use it, which is does not allow a smoke of from bottom below area to upper area. So this is a mandatory requirement of this. And this is the unitized panel. It's a male-female system. If you can see this, the panel comes on the panel. Then there is a vertical. You can see this. The other panel comes here and it goes into here. So it's a male-female system, and it goes in sequence. It doesn't go in one by one panel. It goes and it goes in sequence. It doesn't go in one typical. It has to go in flow. So same way you can see this. This is a fire smoke seal. Again, I'm giving it. It's shown as the bracket, the panel. How the bracket has been installed. This is the bracket has been installed. The panel has been bolted over here, and there's the other panel is coming here, and this is the glass. So it's a DGU glass again we installed over here. This is a fire smoke. And then we told about that okay, as per the norms, NBC norms, we need to follow the openable vents, which we are given in the facade also. This is a design based report that every 10 meter we have given a facade openable vents, which is up about 1.5 by 1.5 meter by 1.5 meter. This is basically for the smoke evacuation in the case of smoke. So this is a typical design of the openable vent. There is a handle, the system, there is a there is a transom, and there is a outer frame, and there is a shutter frame, and the glass has been given. So this is can be open in up to the 15-degree maximum, which is locked also, which can be open more also, but it is does not required because it become going to be a safety violation. So this opening have been restricted to 15-degree maximum. So if you see that there are a lot of other area I told that the duct area which we have used as a aluminum louvers, which gives the fresh air basically is the aesthetic plus for the HVAC it should allow the fresh air to go inside. And we cannot use over glass over there or any stone over there which will become a dead, and then HVAC doesn't work. So to give aesthetic look and the fresh air to go inside, we have provided the louvers, and louvers has given an angularity where the airflow goes from inside and gives a 60% of the airflow which is going inside, which is required for the HVAC. So if you can see, this is the facade looks better. If we put a del, the HVAC will not work, and if it's left or open, then it will look very bad from the aesthetic point of view. So this is also we are told about the pink area, which is a cladding area. We used the aluminum cladded material, which is the PVDF coated aluminum sheet, which is used to basically on a dead wall area for the aesthetic purpose. This is the typical detail of the the cladding material which is there. There is a bracket which comes on the wall. There is a tube which is aluminum frame. Tubes goes into the framing as a back structure of the cladding material, and there is a cladding material which is banded on a 90-degree, and it has been bolted. It's a drag. With the bolted with the system. So if you can say this is the cladding material which has been installed over here. There are also perforated sheet which we are used in a certain area, which only for the aesthetic view on a terrace level, which have a perforation where we have a air circulation, air flow from inside. But it is only from the top view. There is aesthetic requirement. We have provided this. The same system goes again in the same because the aluminum cladding and the perforated aluminum has a main system is a common system. We have used it. The stone, which we have told that again, the stone we have used is a mechanical system. It's a mechanical fixity system. We are given a use of 24 mm hard stone granite we have installed in the building. So these are the typical louvers which is there. We are given shown the louvers of elliptical louver of 290 mm is a bigger louver we have installed. So this is a typical look when from the we can see from the section. So there is a airflow is going here, but there is no water is going from. So there is a HVAC area over here, and there is a framing system. So this is the framing, the louvers in the angularity we are given it. We are told about the skylight. The very huge skylight we installed. This is the installed skylight. You can see this is when we made the design. This is the typical DBR stage, and then eventually we have come out with this glass. The entire glass is with the laminated glass. The laminated DGU, that means upper 6 is a performance glass, then the 16 mm is air gap, and below are the laminated glass, which is 13.52. So we have taken the light of 150 kg live load we have taken consider. The entire structure standing upon the MS structure, and there is a secondary structure which is the aluminum. On the aluminum structure, the entire skylight has been installed over here.
The skylight is over which part of the
it's a podium level part. It is on around 20 meter of that level height.
Okay, done.
So this is basically a system which with the MS structure has been used over there. And these are I think we have covered them. So I think we are given the basic detailing of the unitized glazing, the cladding material and the stone. So there are a lot of products which we install, and every system has its own typical details.
So, Mr. Mittal, thanks a lot for your very wonderful and informative presentation. Actually, the presentation was very informative. In fact, after going through, there are two important questions arriving in my mind. Ki architect does lot of things, each and every design part of the building. But irrespectively, when a facade consultant is um, in the project?
Sir, Eva mentioned about the 2 points. One is the first of all, the responsibility was the facade consultant. Yes, we are the part of the project, so we always will be there. But during the design stage, when we release the tender, so we do our calculation of studies and everything. We have own structural engineer who makes the reports, and the reports has gone with the tender. So whenever we release the tender, it is already done with the structure calculation. However, further when the project is awarded to the vendor, then vendor himself again does the second checks with himself, and if he has some modification with respect to the site, he made again do the calculation and send it back to us for rechecking. And then once we find out that it's in line with the requirement and it passes the wind pressure, we approve the calculation on a based on calculation the installation goes under that. We normally visit the site and we see that everything goes against the shop drawing and the calculation. Apart from this, there is the overall submission is required at the end of the project, which is required the as-built drawing, the eventually what the building has been done. So that's with the as-built drawing. There are a lot of warranties been submitted from the various product. Like if you talk about the installation of the facade, with the 10 years warranty will be provided by the facade contractors, which is for the system performance what we have installed. Second, there is a lot of glazing warranties which is given from the silicone supplier. There are glass coating warranties which is supplied by the glass manufacturer. There are other warranties like glass processing, the DGU glass processing. There is a warranty on glass processing. There are other ACP, other stone or maybe ACP products. So there are again 10 years of warranty of the color fading and the lamination of the a product which is given. There are a lot of back warranty. If you have automated doors, hardwares are given for 3 years, 5 years, depending on the what is in specified in the tender. So overall, all the official completion of the project, the entire document is given to the client with the all backup warranties. So this is the back structure, overall warranties which I have touched upon. Regarding the fee structure, I think consultants are different consultants work on different platform, and I think that is one-to-one case studies and project sizes, and the fees has been decided. Sometimes lump sum, sometimes on square feet. That's a one-to-one discussion. However, facade costing part, whenever the design-based report has been done, what we do that the preliminary drawings, we take out the entire quantities of the facade and we make a draft BOQ. It is not a final BOQ. It is just a BOQ which is derived on the elevation derived by the architect, and we put up the from our expertise. These are the benchmarking prices, and we come out with the some budget. If you want to go with this elevation with this kind of material, this will be this costing. If you're going with other material, then there will be have a different costing. And before going to the final designing, this budget has been approved by the client, and then we work on the tender, and tender has been released for the bidding purpose. So the client always knows that the tender has been released, which has a X amount, and during the negotiation he will try to reduce what best possible can be done. Thank you.
Okay, thank you, Mr. Mithul, for really explaining it beautifully with your case study. And thank you, Purushottam, for
Thanks a
really
lot,
being
ma'am.
there and moderating it so beautifully and asking very valuable questions. Thanks, everyone, for your patient hearing.
Thank you very much, ma'am,
Thank you
for this
all of-
opportunity. Thank you
Thanks
very
a
much.
lot.